goal is to not have any finals at all second semester. You guys all get B's or better. That's my goal.
Because you have algebra 2 classes.
No, just this class, I mean.
Oh, they're only seniors?
Yeah. Usually there's a junior or two, but there isn't. All right. We're going to do 1.5b. And we're going to solve equations today. We're going to solve log and exponential equations, both kinds. So I have 4 exponential equation examples, and I have 5 log examples. I don't know if we'll have time for all of them. We'll try. Here we go. Letter A. Let's solve some exponential equations. Okay, what you want to do with the exponential equations, and some of you guys already know how to solve them because I had problems that I told you could graph and find the intersection. You're like, no, I'd rather just take the log of both sides. I'm like, perfect, yeah. And that's great. Okay, so what you want to do is you want to isolate the power and then take the log of both sides. And you can use either natural log or log base 10. It really doesn't matter. So let's start. Here we go. 8 plus 5 to the x plus 2 is equal to 208. And we're going to round to 2 decimal places is fine if you need to. Okay, so we're trying to find out what x is. Here's a very complicated equation to solve. We're trying to look out what x is. We're going to subtract 8 first so that we isolate the power part. So I get 5 to the x plus 2 equals 200. And then here's the part where you want to log both sides. Now, do you prefer natural log or log base 10? Log base 10? Okay, doesn't matter. I'm just going to log both sides. Yeah, you just... Yes, you'll need your calculator. That's why I went and grabbed mine. Yeah, you either write log or ln. Yeah, it's the same exact thing. So we log both sides of the equation. And then you're going to use the property that tells you to take the exponent and move it down to the front. Because you're multiplying. X plus 2 times log 5 equals log 200. Bless you. Now it's not perched up there anymore. And so the rest of it is just kind of simple algebra. We're just going to divide by log 5. The logs do not cancel out. Don't ever do that. Okay, log 5 over log 5 reduces, leaving us with x plus 2 equals, and we can figure this out by using our calculator. You'll do log 200, and your calculator gives you a parenthesis. Make sure you close that parenthesis. Divide it by log of 5. 2 is fine. And then you get 3.29. Approximately. Why is it cold in here? I'm sorry. Here, let me go change it for you. X equals 1.29, approximately. Okay? Do you remember doing these last year? Yeah, good. Okay. Well, because the next one's actually a word problem, and then there's some that are going to be things you haven't seen. Okay, let's say that you bought a mutual fund for $1,000. And it's going to average 2.5% annual growth. Okay, we did this a while ago, but now we're going to solve it algebraically instead of graphically. How long will it take to triple? How long will it take to triple? Triple with 2 P's or 1? It's 1. Okay. It looked weird, though. Maybe it's because I wrote it out so far. All right. So annual growth. This is just very simple 1 plus r to the t. Okay. So we're going to have 3,000 in our account at the end of all this. And it's equal to 1,000 times 1.025 to the t. Okay, and that's using that formula that we had the other time. All right, go ahead and solve that. Divide by 1,000. It's not even all the way All right, divide by 1,000, you get 3. And some of you guys already, know how to do this because you were doing it when we did these earlier this year. Teach you how to, you can just take the natural log of both sides. It doesn't matter. So you get ln of 3 equals natural log of 1.025 to the t, but the t comes down to the front, and then divide by the natural log of 1.025. So t will equal, and you could do regular log or natural log, we'll still get the same answers. What'd you get? Did you get it already? 40 what? 44.1? 49 years. Wow, that's a long time. No, you're not dead. Okay, let's do number 3.
Oh, gosh.
All right, I'll shorten it to 3. This is the last one. But this one you do not know how to do. I guarantee you don't know how to do this one. No offense. Okay, number 3. Suppose you have 4 to the x plus 6 times 4 to the negative x equals 5.
You can't take the log of both of them?
No. No.
Cancel.
Nope.
Combine them?
Nope. All right, here we go.
How much do you divide by 6?
No. This is very complicated. Here we go. I'll show you how to do these types. You have 4 to the x plus 6, and let's change this. Instead of 4 to the negative x, it's actually 1 over 4 to the x. And you're like, well, that didn't help. Not yet. Okay, and of course we don't like fractions, so let's go ahead and we're going to multiply this entire side by 4 to the x, and this entire side by 4 to the x. All right? So when we do that, we distribute, and 4 to the x times 4 to the x is 4 to the 2x. The base stays the same, and you add the exponents, right?
It would be 4 times 4?
Because like if you did x to the third times x to the second, the x's don't change. It's x to the fifth, right? It's not 2x to the fifth or x times x. It's, yeah, the base stays exactly the same. The 4, you just add the exponents. Plus 6 equals 5 times x to the 4th. And you're probably still thinking that didn't help much.
Do you distribute to all of them?
Oh, why didn't you
I did.
change the x to the 4th, not 4 to the x?
Oops. Oopsie woo-woos. That's a good question. It shouldn't have.
Shouldn't you just divide it 6 though?
4 to the x, my bad. Okay, now what we're going to do is we're going to get everybody over on the same side. So we have 4 to the 2x.
Wait, you don't distribute to the 6 at all?
I did. This was 6 times 1 over 4x, so the
It's not
4...
in parentheses, though.
What?
Oh, you combine the 6 times the 1 over 4x.
This is 6 times 1 over
So
4x.
then the denominator is canceled out.
4x and 4x will reduce out. Yeah. Okay, sorry. So minus 5 times 4 to the x plus 6 equals 0. Now, whenever I see a trinomial like that, I'm thinking factor.
No, I think I do factor.
You do. You factor it.
Yep, there is.
Here we go.
What's the life lesson in this? What do we
Life lesson. There's no life
When
lesson.
do we use this? There is no application.
No,
Just
we don't ask that
tapestry.
question.
Tapestry.
All right. So if you can't see it, it's really hard to see to factor this. If you let z equal 4 to the x, okay? If you let z equal 4 to the x, that's going to be a little bit better because here you'll get z squared, because 4 to the x squared would be z squared, minus 5z plus 6 equals 0. And it's actually better to factor this and then go back and substitute back in. So you get z, what times what 6 adds up to negative 5? It would be a negative 3 and a negative 2. Okay? So you get z minus 3 equals 0, and z minus 2 equals 0.
Why should you choose z of all others?
I don't know. I could have chosen something else. All right, so we get 4 to the x equals 3. So go ahead and substitute z back in, which is 4 to the x. 4 to the x equals 3, and 4 to the x equals 2. And then from here you can log both sides. Log of 4 to the x equals log of 3. So x would equal log 3 divided by log 4, which is approximately, it is a lot of work for one problem, huh? 0.79. And over here, same thing. Log both sides. So x would equal log 2 divided by log 4, which is what? 0.5? Oh, yeah. Equals 0.5. And there you go. You get 2 answers for this. That's a pretty decent sized problem, huh? That might be like a bonus type question on the next quiz on Friday. Okay? All right, so we did 3 log or exponential problems. Now we're going to do, I think I have 4. We'll see. We'll see how many. All right. This is part B, yeah. So we'll do some log equations now. Now, log equations, what you want to do, and remember about log equations, is once you get the log by itself, people get stuck. And they're paralyzed. Like, what do I do now? Because you're not taking something to both sides. You know, like exponential equations are easier because you log both sides. Square roots, you square both sides. You know, you do something to both sides. With logs, you don't. That's what makes them really hard, okay? For log equations, what you want to do is you want to take the log and rewrite it in its exponential form. So you're not doing anything to both sides. So let's see some. Number 4. So let's say that we have something like this. Log of 4x minus 4 equals 2. Okay? Now, you can't take you can't add 4, you can't divide by 4, you can't take anything out of here, but what you can do is get rid of the log by writing it in exponential form. Like if I asked you to evaluate, what's log base 2 of 8? You know, you rewrite it in your head as an exponent. That's what we're going to do here. The base is 10. We're going to go 10 to the second equals 4x minus 4. Do you remember this? Do you remember getting stuck at that part? A lot of people do. Okay? It's just hard to remember. It's like, no, the problem's not hard. It's just, what do? I can't log both sides because that's logging the log. That doesn't get rid of it. How do you get rid of a log? It's by writing it in exponential form. So you get 100 equals 4x minus 4. 104 equals 4x. So x is 26. Now the other thing tricky about these problems is that you could get an extraneous solution on log problems. So exponential, that's okay, because the domain of an exponential function is all real numbers. But log, you can't take the log of 0 or negative. So you have to kind of look at your answers to make sure they work. All right, let's try another one. Number 5. Suppose you have log x plus log 8 equals 3. Now we have more than one log. So what we're going to do is we're going to combine the logs together first, and then we'll get rid of the log, okay? So this becomes the log of what?
8x.
Perfect. 8x equals 3. And then this brings us back to the last problem, what we just did. And so we'll rewrite this in its exponential form. The base is 10 again, so 10 to the third equals 8x. You get 1,000 equals 8x divided by 8, and x is 125. And there's no problem with that. If I plug it in here, that'll work very nicely. Okay, let me show you one that gives you extraneous solutions. Number 6. Suppose you have 2 log x minus log 3 equals 4. Okay, There's a couple ways to do this problem. Most people would combine it into one log, which you can. So if you were to combine this side into one log, you'd have an x squared over 3 equals 4. Okay? So you're pretty good with your properties. Pretty solid on those, I hope. And now let's go ahead and rewrite it in its exponential form. 10 to the 4th equals x squared over 3. 10 to the 4th is 10,000 times 3 is 30,000. So I get x squared equals 30,000. And when I solve this equation right here, I get x is equal to plus or minus the square root of 30,000. Okay, except the negative won't work. So if I go back to my original equation, see how x isn't squared yet? Like if I started here, that would be cool, because then they would both work. Because when I square negative rad 30,000, it becomes positive, and I can take the log of a positive number. But I'm going back to the very original one.
So you can't take the log of a negative number.
You cannot. Try it on your calculator, you'll see. So then this one right here, the only answer would be log of rad 30,000, which is whatever that is. There you go. Sometimes I'd rather just leave the answer like this. It looks nicer. 173.21. There's only one answer here, okay? So it looked like there were going to be 2. And it's funny because some people will do this wrong and get it right. So they'll forget to take the plus and minus square root of both sides, you know? And then they'll get it wrong. I mean, they'll get it right because they didn't. Anyways. Okay. All right, last one, number 7. Just because you'll probably see one of these and then you'll get stuck, and I would hate for that to happen. All right, you have log of 2x plus 3 equals log of 15. Now, these are those problems that you get stuck on because you're like, okay, 10 to the log 15 and 10 to the... No. Look at it a much easier way. Log of stuff equals log of stuff.
15 equals 2.
So stuffs have to be equal. Yes, mathematically speaking, the stuffs are equal. All right, so 2x plus 3 has to equal 15. That should make sense, right? Log of a number equals log of another number. Those numbers should be equal to one another. So x equals 6. Perfect. Nice. You like those. All right.